I'm Anil Kumar, and now let us take our discussion on writing quadratic equations from zeros to the next level. The question here is, find the quadratic equation in the form of f of x equals to ax squared plus bx plus c for set of zeros as minus 4 plus minus 5 square root 2 divided by 6. Now in this particular case, we have radical zeros. How to find quadratic equation in standard form from such zeros? That is the idea to explore in this video. Let me start with a very general and explain you the theory behind. Okay, so let's begin with a quadratic equation as given to us. Let us say the equation, I'm just rewriting the standard form of equation, ax squared plus bx plus c. Now if I need to write solution of this equation, I can use quadratic formula, and I say x equals to minus b plus minus square root of b squared minus 4ac divided by 2 times a, right? So that is the quadratic formula, right? Now compare the zeros with the equation, you will get an idea. So if you compare the zeros with the equation, what you notice? You notice that 6 is 2a, right? So we could say 2a is equals to 6, and that means a is equals to 6 divided by 2 or 3. Perfect. How about b? Minus 4 is equal to minus b, and that means 4 is equals to b for us. And how about this number? 5 square root 2. Well, it means that b squared minus 4ac within the square root is 5 square root 2. Let us rewrite this 0 in a different way, right? So I'll rewrite the 0 in a different way so that it becomes easier for us to compare. We could write this as minus 4 plus minus within square root. If I take 5 within square root, it becomes 5 square, right? So 5 square is 25, right? So we could get 25 times 2 as 50. You get an idea, right? So 5 square and this divided by 6. Do you get it? Let me show you this work once again. So let me redo this, right? So we have here minus 4 plus minus 5 square root 2 over 6, right? So what we are doing here is we are writing this as minus 4 plus minus. When I take 5 inside the square root, it becomes 5 square, right? And there's already 2 here. Do you get the idea? Over 6, right? Now, next step will be 5 square is 25. So we have 25 times 2, right? This dot is multiplication, correct? And that gives us 50. So we get minus 4 plus minus square root 50 over 6 as I wrote, correct? Anyway, this helps us to equate b square minus 4ac with 50. So from here, what we can say is that b square minus 4ac is indeed equals to 50, right? So comparing these two. Now we know what b is. B is 4 for us. We know what a is. A is 3 for us. So in this equation, only c is unknown, which we can calculate. That's the whole idea, right? So we'll substitute b as 4, right? So we'll say, now let's redo. So b squared minus 4ac is equal to 50, right? Now for us, b is 4. So I'm writing 4 here. So 4 squared minus 4 times a is 3 times c is 50, right? Now we can actually take 4 squared to the right side. So we have, or let me read down, 16, 12c, 50. We need to solve for c to get the equation, right? So we get minus 12c equals to 50 minus 16. And that should be equals to, so when you divide this minus this, so you get 4 here, right? 10 and 4 take away 1 is 3. So we get 34, right? So we get 34 is minus 12c, or c is equals to 34 divided by minus 12. Both can be divided by 2, simplifying this to minus 17 over 6. So that becomes the value of C. Once you get the value of C, you know A as 3, B as 4, C as minus 17 over 6. So you can write down your function. So we say, well, now the function f of x could be written as A is 3, so A is 3x squared, plus bx, b is 4, so it is plus 4x, plus c. C is minus 17 over 6. Now it is always a good practice to write your equation without fractions. So I'll multiply each and every term with 6, and I can write this my function as f of x equals to 6 times 3 as 18, right? 18x squared, 6 times 4 as 24, so 24x minus 17. You get the idea. So that becomes a quadratic equation for which the roots are minus 4 plus minus 5 square root 2 over 6, right? Now what you can do is, you can actually find the solution of this equation and check, do you get the same roots? I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.